welcome to Utkarsh Minds Python for Data Science. Today we will see what is kernel density estimation in Python. So we will need a new notebook and I will write the name as lesson 23 kernel density estimation in Seaborn. So kernel density estimation is a useful technique of Seaborn for plotting the relationship between the different variables. Here I will need pandas, I will need numpy, I will need Seaborn, and I will need to load the data set. So Seaborn dot load data set, and here I am writing the name of the data set as penguins. So the penguins data set has information about the flipper length, bill length, depth, body mass of various penguins. Let us see how kernel density estimation can help us in understanding this data better. So we have data, we will, let us say, take body mass, and here I have to write kind as KDE, which is kernel density estimation. So you can see that maximum density is concentrated here in this region. However, we can also have some changes. For example, we can check for different variables that we have. Let us say we have a hue parameter and we can test it with respect to the different species. So we are getting the individual species. Just so that we can have represent the same information maybe in a different manner, we can write here multiple. There are several options in multiple. We can take the option of stack. That will stack these one above the other, but this leads to hidden things. So instead of stack, we can have some change and we will write a we will say fill, and the parameter fill we will put as true. Now you can see the difference, that although they are in front of each other, they are not overlapping, and that is the importance of this kind of parameter fill equal to true. That was the kernel density estimator. Along with that, there is also one empirical cumulative distribution function. So this gives us the distribution of the different data points. Again, I am writing the same function displot, only I am changing the kind as ECDF, empirical cumulative distribution function, and multiple has to be removed here. So let us see how the distribution is. Maximum data, you can see that majority of the data points are between 4500. Only for Gen 2 it goes up to or greater than 6000. This is the proportion of the data that lies within this interval. So if I put my point here, that means 60% of the data is less than 4000. So that is the use of this kind of plots. Along with that, many other kinds of data also we can get. Let us see the same Seaborn displot. Here I am having on X the body mass, and on Y I will have the bill depth mm. So this kind of this plot will tell us the distribution. So this is darker region, that means concentration is high. So where body mass of 3500 and build depth of 18 is a higher concentration, but body mass of 5000 but build depth of 22 is very low. That is the advantage of this kind of color maps. We can also have a argument here like C bar, which is the color bar. I will set that as true, and you will get a color bar from 0 to 18. So each color here represents a value here. That is the advantage of this kind of plots, which is displot. Next, there are some other type of plots also that can be done in Seaborn. So Seaborn, this one is known as the joint plot. So the data will still be penguins. I think the data variable is data. X and Y axis, I will take body mass and build depth. And here I am there is no need for any further arguments. So here we have got the joint plot. You can see that body mass is at this range, whereas the build depth is located in this interval. Along with that, there are many kinds of things we can do here with this kind of plots. Let us set the kind argument to KDE. So if I set it as KDE, then we will get a different plot. We will get a KDE, kernel density estimation plot of build depth and mass. Here the body mass is distributed in this way, whereas the build depth is distributed here, and jointly it shows us in which range majority of the species are located. So in this range there is majority, and this point here, that is where the concentration is. That is how we can plot the different data jointly. Otherwise also there are some other plots which are not so common, but still we will mention them here. One is the Relplot. It does not have a kind parameter. It gives the scatter plot of data, and then comes the Rugplot, Rugplot. This plot, it gives the the concentration of the data points. It is maximum concentration of body mass is here, whereas maximum concentration of build depth is here. We can also combine this Relplot and Rugplot in the same thing. For example, we can have a Relplot followed by a Rugplot together, and here we are getting the same plot with both Rug and the Rel. So these are the different things that you can do. And finally, last but not the least, if you want to plot a lot of things at the same time, then this Pairplot argument is very useful. It gives us a complete plot of the different different combinations of data. For example, bill length versus bill length, bill depth, flipper and body mass. So all the numeric values, numeric quantities are taken and captured in this single plot. In this way, we have seen multiple uses of the Seaborn library and the different plots. Interpretation of data is a challenge. Drawing conclusions is a challenge. It depends upon the type of data and the data set and the plot. But when there is numeric data, let us say numeric versus numeric data, then such kind of plots are very useful. So keep practicing on other data sets and see you in the next video.